Problem 4, we're asked to find the graph, sketch the graph of this function using n behavior. Well, if we count up the degrees, the powers of each of the factors, we have a 1 plus 2 plus 1, and that's 4. And we could see we have a negative here, so a is negative. And if a is negative and the degree is 4, then basically we have a graph that looks like y equals, sorry, I was about to write n behavior model. So we have an n behavior model that resembles y equals negative x to the 4th, which we know when the a is negative and the degree is even, we have the ends of the graph opening downward. Well, now what do we do with this big mess it could look like? But if we know how to translate it, it's not too bad. When we see a factor of, where's my red? My red pen. There we go. When we see a factor of x minus 2, we know that that means that there's an x-intercept of 2. And an x-intercept of 2 means if you replace x with 2, 2 minus 2 being 0, then when you put a 2 in for x, then this factor is 0, and so y is 0. So that's why a factor of x minus 2 means an x-intercept of x equals 2. And so then try to figure out what I'm going to say here. If we have a factor of x plus 3, even though it's to the second power, it's still a factor. What value of x would make that factor equal to 0? Well, negative 3 plus 3 is equal to 0, so a factor of x plus 3 means we have an x-intercept of negative 3. And then likewise, when we have a factor of x minus 4, it means we have an x-intercept of 4. So if you remember the Math Invaders story that we told about this kind of a scenario here in graphing a polynomial function, we're going to start from the south and we're going to go north. So if we start from down here, we're going to go up to this x-intercept. The question is, what's the behavior of the graph at that x-intercept? Well, if you remember, that factor right there, x plus 3, that corresponds to that x-intercept, has a power of 2. So when it's a power of 2, when we approach from down here, we don't go through it. We have to sneak up on it and just hit it and then go back down. So a factor of power of 2 means that we're just going to come up and touch the x-axis at that x-intercept, and then we're going to come back down. Well, each of the other factors has a power of 1. If the powers are 1, that means we're going to go right through the x-axis at those x-intercepts. And then we're going to come right back down through, and we can notice here that our overall graph looks a lot like our n behavior model, which we knew that the graph would look somewhat like that. The ends of the graph are coming down, and so when x gets really big positive, we know that y goes to negative infinity. When x gets big in the negative direction, y also approaches negative infinity. Number of turning points, we have 1, 2, 3 turning points, and we have x-intercepts. We already talked about those, negative 3, 0, 2, 0, and 4, 0. And that's how to do a problem in which you have to graph the function, a polynomial function, when you're given the equation that is already factored. You're going to always set the factors equal to 0 to find the x-intercepts, and so on and so on. Well, let's go ahead and do problem number 5 here. If we have to set the factors equal to 0 to find our x-intercepts and there's no factors, that means we're going to have to factor. So we should notice automatically here that we have a common factor of an x, and so we're going to factor out an x, and we get x squared minus 5x minus 14. When you factor out an x, there's 3 of them here. When you factor one of them out, there's 2 left. Here we have 2 x's. We factored one of them out. Hold on. Factored one of them out, and we're left with 1. Okay, and again, we have 1 x here. We factor it out, and we're not left with any more x's. So we still, though, should recognize that we have a trinomial that needs to be factored. My favorite way of factoring is realizing there's 3 terms. The only way to factor 3 terms like that, besides the greatest common factor, is by foiling it. So we have x times x equals x squared. 7 times 2 is 14. Negative 7 times positive 2 is negative 14, and negative 7x and a positive 2x gives us a negative 5x. And so all we did was we rewrote the polynomial function in its factored form, which then leaves x as a factor, x equaling 0 gives us one x-intercept of 0. X plus 2 equals 0 means that x has to be negative 2. And x minus 7 equals 0 means that x has to be equal to 7 as an x-intercept. And so we know that this is a third degree polynomial. The a is positive, so we know it goes up from left to right. Each one of these factors has a power of 1, so we go straight up through the first x-intercept, down through the second x-intercept, and up through the third x-intercept, and we have a graph that looks a lot like our end behavior model. And that's it. So we see that as x approaches positive infinity, we see that y goes up toward positive infinity. And then as x approaches negative infinity, if we move to the left on the graph, the y values are getting lower, and that would mean that then we would write that as y approaches negative infinity as x approaches negative infinity. There are two turning points, one relative maximum, one relative minimum. And the x-intercepts, like I said, we already talked about, negative 2, 0, 0, 0, and 7, 0. There we go.